Now that we know exactly what's the outbreak rule for each type of transformations, let's consider their inverses. Now, what's an inverse transformation? An inverse transformation, T inverse, is called the inverse of T if T inverse of T of P is P. In other words, T inverse completely undoes T, or in other words, T is a mapping between some points to another set of points, and T inverse is its inverse. Combinations of multiple transformations is like composite functions, but in terms of transformations of points. Inverse of translations are just as follows. For the forward translations, we just add h, we add k. And in order to undo those, we minus, we take away h, we take away k. And we see that this inverse is indeed the one that matches the definition, since the composition of T and T inverse gives us back x naught and y naught. Similarly, the inverse of dilations is simply 1 upon a times x and 1 upon b times x. And the application of T inverse to T of x is simply x naught and y naught, since division undo multiplication. The inverse of reflection is just itself, because it's just another reflection. And obviously, two reflections get us back to the original point.